Today I am with the lesson classification of elements based on electronic configurations. From this lesson, the points to be learnt are introduction to periodic table, S block elements, P block elements, D block elements, and finally F block elements. So let's begin. The very first point is introduction to periodic table. First of all, we will see the definition of periodic table. In this periodic table, there are 118 elements. These 118 elements are arranged according to their atomic numbers. Atomic number 1 position is first position. Atomic number 118 position is the 118th position. So elements are arranged in this periodic table according to their atomic numbers. Now let's see the definition of periodic table. The table or chart where elements are arranged according to their atomic numbers, this table is called periodic table. Now, periods. In this periodic table, there are some horizontal rows. There are 7 horizontal rows. These horizontal rows are called periods. There are total 7 periods in this periodic table. Those are period 1, 2, 3, 4, 5, 6, 7. First period contains 2 elements, hydrogen and helium. Second period contains 8 elements. Third period contains 8 elements. Fourth period contains 18 elements. Fifth period 18 elements. Sixth period total 32 elements. Let's see how 32 elements are present here. This is 2 cesium and barium. Here total 15 elements are present. Atomic numbers from 57 to 71. Actually these are those elements. Lanthanum to lutetium. These 15 elements are supposed to be here because of their close similarity. But it is not possible to keep in one place these 15 elements. That is why these similar type of 15 elements are placed beneath the main periodic table. So here is actually total number of elements 15. So this is 2 plus 15, and after that here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Another 15. So here 6th period total 32 elements. Now 7th period similarly 2, here 15. Atomic number 87 to 103. That is 2 plus here 15, and after that here 15. So total 32 elements. Now groups. In this periodic table there are some groups. Actually total 18 groups. These vertical columns are called groups. According to modern periodic table, these groups are named as 1A, 2A, this is 1B, this is 2B, this is 3B, 4B, 5B, 6B, 7B. These 3 columns are together column 8. Then Here 3A, 4A, 5A, 6A, 7A, and the name of this column is 0 in the modern periodic table. And in the most modern periodic table, these columns are named as just 1 to 18. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So in this periodic table there are some vertical columns. These vertical columns are called groups, and these groups are named in modern periodic table this way, 1A, 2A, like this. And in the most modern periodic table, the columns are named simply 1 to 18. Now, lanthanide series or lanthanoids. The series of 15 elements, total 15 elements here present, lanthanum to lutetium. These 15 elements are called lanthanide series. The head element is lanthanum. According to the lanthanum, this series is named lanthanide series, and its another name is lanthanoids. And in this series there are total 15 elements present. These 15 elements are supposed to be in this place, that is atomic numbers lanthanum 57 to lutetium 71. But to keep these 15 elements in one place, it is very tough or difficult. That is why these 15 elements are kept beneath the main periodic table, which is called lanthanide series or lanthanoids. The head element is lanthanum. According to this word, this series is called lanthanide series. Now, actinoid series or actinoids. These 15 elements here, actinum to lawrencium. These 15 elements are called actinoid series. The head element is actinum, and according to this word actinum, this series is named actinide series or actinoids. Actually, these elements are supposed to be here because of their close similarity, that is atomic numbers 89 to 103. But to keep these 15 elements in one place, this is very difficult. That is why these 15 elements are kept beneath the main periodic table, which is called actinide series or actinoids. So these 15 elements are called lanthanide series or lanthanoids. Another 15 elements are called actinide series or actinoids. Now, classes of elements. In this periodic table, there are total 118 elements. These 118 elements are divided into 4 classes. Those are S block elements, P block elements, D block elements, and F block elements. S, P, D, F, these are small letters, not capital letters. So here let's see what are S block elements, what are P block elements, what are D block, and what are F block elements. In this periodic table, elements of column 1 and 2, including helium, that means 1, 7 elements, 2 here 1, 2, 3, 4, 5, 6, and helium plus helium. So total 14 elements. So S block elements total number is 14. This S block elements including helium. plus helium, and its number is 14. Now p block elements. Elements of column 13 to 0 excluding helium. 13 to 0 excluding helium are p block elements. Here let's see the number of p block elements. 1 2 3 4 5 6. 1 2 3 4 5 6. 6 into 6, total 36 elements are p block elements. Now let's see what are d block elements. The elements in the middle of the periodic table, that means these elements. The elements in the middle of the periodic table is called d block elements. Here total 37 d block elements, 37 plus these lanthanum 1 d block elements plus these two actinum and thorium, these two total 41, 38. It will be 38. This plus 1, here total 38 elements are here, then plus 1 lanthanum and another 2, so total 41. 48 elements are d block elements. Now f block elements. These are f block elements, excluding here from lanthanoids, excluding lanthanum, and for actinoids excluding actinum and thorium, total this number. It is actually f block elements. The number is actually 1 2 3 4 5 6 7 8 9 10 11 12 13 14. 14 plus 13, 14 plus 13, total 27. So these are the numbers of different block elements. S block 14 elements, P block 36 elements, D block 41 elements, F block 27 elements. These are the classes of elements. Next point, we will learn how these elements are S block, how these elements are P block, why these elements are D block, and why these elements are F block elements. Now, arrangement of orbitals. Following n plus L rule, all the elements are arranged according to their energy. Lowest energy orbital is taken first and then higher energy orbitals. And accordingly, the lowest energy orbital is 1s, then 2s, then 2p. And we will get here 5f, 6d, 7p. You can see on the screen all the orbitals are arranged according to their energies. And in distributing the electrons will enter first this orbital, then this orbital, then this orbital, and so on. This is actually arrangement of orbitals. Let's move on to the next point. Now the point is S block elements. Now we will see why these are S block elements. Elements of column 1 and column 2 including helium. So here 7, here 6 and another one. Total 14 elements are S block elements. Now we will see why these elements are called S block elements. Let's see first the definition of S block elements. The elements in which last electron enters the S orbital in electronic configuration. Let's see first sodium, atomic number 11. The 11th electron enters the S orbital. 1s2, 2s2, 2p6, 3s1. So 11th electron enters the S orbital. That is why sodium is S block element. Let's see another one, calcium 20. Electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. That means the 20th electron enters the s orbital. Let's see another one is strontium 38. Electronic configuration is 1s2, 2s2, and finally we will see 5s2. That means 38th electron enters the s orbital. This is the reason that these elements are called S block elements. Let's see the next point. Now, P block elements. Similarly, like S block elements, the elements where last electron enters p orbital. The elements of column 13 to 18, excluding helium, are called P block elements. Let's see some electronic configurations of some elements. First of all, let's see aluminum. Aluminum is 13. Electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p1. Total 13 elements, 10, 12, 13. The aluminum is the element in which last electron enters p orbital. That is why aluminum is a kind of P block element. Let's see another one. Sulfur 16, 1s2, 3p4. That means last electron enters p orbital. That is why sulfur is a kind of P block element. Let's see another one. Xenon or bromine 35. 35, 1s2, and finally we will see 5p5. Last electron enters p orbital. Another one, let's say xenon. This is 54. Last electron enters 1s2, 5p6. That means last electron enters p orbital. So the elements in which last electron enters p orbital, those are called P block elements. Here total number of P block elements 36. Last electron enters p orbital, here p orbital, here p orbital, and p orbital. If we see electronic configurations of all the elements, we will see last electron will enter the p orbital. Here it will be 4, 2, 3, 4. Here it will be 4p5. Let's see the next point. Now the point is ideal or representative elements. These are S block elements including helium, and these are P block elements excluding helium. S block 14 elements and P block 36 elements, total 50 elements. These 50 elements are called ideal or representative elements because these elements follow general rules in filling orbitals with electrons without any exception. This is the reason these elements are termed as ideal or representative elements. Let's move on to the next point. Now the point is D block elements. Let's see first the number of D block elements. Here in the middle of the periodic table, this portion contains 38 elements. Here 1 and these 2, actinium and thorium. Total 40 elements are D block elements. The definition of D block elements is the elements in which last electron enters d orbital are called D block elements. Let's see an example first. Scandium 21. Electronic configuration is 1s2, and lastly we will see 3d1. That means 21st electron enters d orbital. That is why scandium is a kind of D block element. Let's see another example. Chromium is a kind of D block element. Chromium 24, 1s2, 4s2 3d4. Here rearrangement happens. Here we see this 3d4. This is not half filled, not full filled. Full filled orbitals are most stable, then half filled orbitals are stable. Here one electrons come here. Then we will see 1s2, 4s1, 3d5. Now these orbitals are half filled, stable orbitals. To be stable, this kind of rearrangement happens here. However, the 24th electron enters d orbital. That is why chromium is a kind of d block element. Let's see another example. Copper 29. 1s2, 4s2, 3d9. Here also last electron enters d orbital, so it's a kind of d block element. But here one thing, rearrangement happens here like this. 1s2, 4s, one electron comes here. 4s1, 3d10. This is partially filled, not full filled, not half filled. But when one electron comes here, then this is half filled, this is full filled, which is a stable configuration. However, copper is a kind of d block element. Let's see another example. Now we will see zinc. Zinc 30. 1s2, 4s2, 3d10. Here last electron, 30th electron enters d orbital. So zinc is d block element as well. Let's move on to the next point. Now the point is f block elements. Here we learned that this is lanthanide series of 15 elements. This is actinide series of 15 elements. From these 15 elements, lanthanum is d block element, and from these 15 elements, these two are d block elements. So the other elements, here 13 and here 14 and here 13. So from the lanthanide series 14 and from the actinide series 13. Total 27 elements are F block elements. And the definition of F block elements is the elements in which last electron enters F orbital are called F block elements. Let's see an example. Cerium 58, 1s2, 6s2, 4f2. That means 58th electron enters F orbital. So cerium is a kind of F block element. Let's see another example. Now let's see protactinium 94. 1s2, 7s2, 5f2. That means last electron, 94th electron enters F orbital. So this is F block element as well. No more today. Thank you very much.